Good evening. So tonight what I want to talk about is go one level down below what Dr. Bull was talking about and talk about how do we encourage STEM education in elementary, middle school, and high schoolers. And this is my point tonight, that we believe that to support innovation and to make STEM cognizant and STEM enthusiastic students, we have to do something and we have to get them to become makers. So what I want to talk about tonight is transforming kids from tech users to tech makers. The key to engaging students in STEM, science, technology, engineering, math, is to put them in the role of maker. So kids generally are pretty good at using technology. They're generally pretty awful at making technology. And a quick history lesson shows us why this is such an important point to understand. If we look back at the retiring generation of Apollo-era engineers, they were almost all tinkerers, makers of some sort. If we want to generate that kind of interest again, we have to start making a new crew of makers. And how do we do that? One way that we're doing that in the Center for STEM Education is using an open source hardware platform called Arduino. It's a simple microcontroller system that allows students to choose a project of their own making and build it. So what I want to talk about is how we're using Arduino, what it is, and then what we're seeing with the results. So, what is Arduino? It's basically, like I said, an open source microcontroller. Students can make something that interacts with its own environment. And the key piece of this that we're finding is that it answers the big question, so what? Students are always asking this, what does this have to do with anything that I am interested in? And the way that we're answering this so what question is by phrasing a question back to them. And that is in the form of tech that helps. Can you make a device, a piece of technology that helps communities, helps people, or helps the environment? So I want to give you two stories as examples. So the first story is about a girl named Jasmine. So she was forced to come to one of our engineering camps. If you asked her what career was she wanting to do, she would tell you she's going to California, become a cosmetologist. All right, cool, no problem. So she came to our camp and she teamed up with an all-girls team, and they chose a tech that helps communities type of model. And they noticed that community gardens often start well but go untended. Is there a way to make basically a Roomba for a community garden? Can we make a robot that can test for soil humidity and alert a user to when the garden needs? It could tweet, it could text when this thing needs watered. They built this prototype in the span of 1 week. So an all-girls team, the main one wanted to be a cosmetologist in California, built and programmed and demonstrated a prototype of a Roomba for a community garden all in 1 week for about less than $100, actually about $80. A second story. So we had a group of middle schoolers from Harrison School District, an underperforming school district, right? These students chose a tech that helps people type of model, and they wanted to pose the problem, can we build a device that would help a senior citizen manage their food pantry? They got a pressure sensor, they taped it to a shelf. You could place cans on that pressure sensor. When the last can left, a light lit up and a buzzer went off. A group of middle schoolers from an underperforming school district in 1 week for about $80 built, prototyped, and presented to a group much like yourself. They're probably about as nervous as I am right now. To a group of adults, their idea. This is transformational. This is an opportunity to take a piece of hardware that has a low entry point, about $60 to $80 per student, and give them an opportunity to make something of their own choosing. So what is the return on investment in this model? First of all, we see that students are becoming makers. And like I said at first, that's a key piece of moving the yardsticks on engaging more students in STEM. Key to that is that failure is always an option. It puts them on a track where they have to think on their feet and do what we call robust failure, troubleshooting on the spot. We also survey kids. One of our mottos is no child left unsurveyed. We survey them whenever they come in. And what we're finding is that this is a very robust way to engage students. More than 3/4 of students are saying that it increased their interest in STEM, and about more than that, about 80% said they want to take more STEM classes. Using open source hardware and open source code. There's very little cost to upgrading, and the software is free itself. So my message to all of us here is let's get out and make something. That is the key to engaging a next generation of innovators and entrepreneurs and STEM professionals. Thank you.